So it started, right? So we'll see that this is equivalent to nothing but this resistor, but the resistance of this will depend upon the intensity of light. So that is what we'll check right now. First, before connecting it to an Arduino, we'll do everything that we can. Okay, we just connected it. And now what we want to measure is the resistance. So we'll click on this multimeter, and within the mode, we'll select resistance. Okay, because we want to measure the resistance of this particular LDR. Now, when we simulate this, I think we don't need a code since we don't have an Arduino attached. So we'll start this. Okay, we see we are getting a resistance of 180 kilo ohm, right? Now, since it's a simulation environment, right? So we can't give a light to it. I can't change the brightness of my laptop and it will record that. So in this case, if we are using a sensor within this simulator, what will happen is if we click after simulating, since see the simulation has started, we'll get nothing. After the simulations have started, we'll get this value. So whatever it's trying to measure, it will give you an option to increase or decrease that particular factor. For example, this is equivalent to light. So so they have given you something, uh, a drag bar to adjust the brightness or intensity of the light that is in the atmosphere that this want to sense. Okay, so we'll adjust the light, right? So let's say the environment light is increasing. We can see the resistance is decreasing, right? It was 180 kilo ohm. It went down to 1 kilo ohm, and now it's around 506 ohm. Okay, so what is happening is as the light is increasing, the resistance is decreasing, right? Uh, First, we didn't have any light, so the resistance was 180 kilo ohm. As soon as the light intensity increases, the resistance decreases, right? So this is what the principle of a photoresistor on an LDR is. Okay, so now since it's an LDR, so last time what we saw is we directly use this module. We had this VCC pin we connected to the VCC. We had this ground pin we connected to the ground. And for digital measurement, we connected this to the digital pin, and then we took the measurement. And for analog, we did this, right? So everything the module itself did for us, right? So we had nothing to do. We just connected it, and every circuitry or anything that will be used with this particular component, the module did itself. We just measured the value, but in component we had to know how we want to measure that value particularly. So there is one way to measure this, right? Since is a resistance, and I'll tell you what happens with Arduino. Okay. So what happens with a microcontroller board is, I told you that while giving an output, it gives out the voltage, right? Now, what happens when we are trying to measure trying to measure the value from the sensor? In the case of output, it gave the voltage. It acted as a VCC pin, right? It acted as a VCC pin and gave out the voltage. But now what we want is to measure. We don't want the voltage to go out, right? We only want to measure. So in this case, when we are using these pins as input, it measures the voltage difference. It measures nothing but the voltage difference. Okay. So
Another
now,
question: what is a
yeah,
VCC?
VCC is a common term. For example, VCC is what we call power, and VIN is what we call a logical power, right? VCC and VSS is a different component. So VCC and VSS is nothing but voltage only. We gave V as voltage, right? And S and C is source and the component voltage, right? So if we want to give power and all, then we mention it differently, right? For example, let's say if we have connected a motor with this, right? If we are trying to connect a motor with this, let's say we should have a motor. Okay, sorry. We want to connect a DC motor with this, right? This is a DC motor. What happens with a DC motor is, let's say it's a powerful motor, and will it won't work with a 5 volt. So what Arduino can give you is only 5 volt, nothing more than that. But we require more voltage to run this particular motor, right? So in that case, we use different logics. And since we have to define two types of voltage here, so what we'll do is we'll attach a different source, right? So I'll just give a battery to it and then attach it somehow. I'll tell you that also. We will be covering that also. So in that case, we want to differentiate between two types of voltage, right? Two types of voltage that we are getting from source. So there are two voltage. First is power voltage, that is just used for running this motor. We say that V power, yeah, VSS, and the second one is a logical voltage, right? So the logical voltage is Vs, what we give from this particular. So okay, I'll tell you that in the future videos. I think today only, if we have time, we could cover. We still have some time. Okay, so I'll proceed with photoresistors for now. Okay, so now what we want is we want to measure this, right? So I told you what happens is in the output case, it gives the voltage out, but when we want to measure, these pins do nothing but measure the voltage in that point. So measuring the voltage in a particular point within the circuit is nothing but a voltage difference, right? And I think we all have studied that we could just give me a second, that we could measure the voltage between 2 points of a resistors, right? So I'm using the logic of voltage. So now I'm doing nothing but connecting this to parallel, in series with a different resistor. The resistor which has an actual value. Let's say I gave it 1 kilo ohm. 1 kilo ohm is enough in this case. And I'll give a source to it, like a battery. So I'll tell you how we'll get the logic. So out. We want to measure this, right? Last time what we did was we just used this module, and this module took care of everything. So how the logic works behind measuring value from this particular resistor, because it's a resistor, right? It's not a sensor, actually, it's a resistor. So we want to measure the value for a resistor. So what we'll do is, let's say, how we'll approach this. So what I did was I just connected this to, okay, I connected two resistors in series and gave them a power supply. Now what I'll do is I'll measure the voltage difference and how it varies. Oh, sorry, my mistake. Multimeter only. Yeah. So in order to measure the voltage difference, I'll first connect the ground to the ground only, or we can say negative. The ground to ground is connected. Now, at what point I want to measure? Since I want to measure at this point, the difference coming from this current is how much difference is from this point to this point, right? So I'll connect this point to the multimeter. Got it, right? So we all must have done this question in school, right? Calculating voltage at a particular point in the circuit when the resistors are connected in series or
Yes.
parallel. Yeah. We are not going for parallel because the Arduino measures voltage, right? Arduino can measure voltage difference, not current. If it could measure current, then we'll go for a parallel connection. Why parallel? Because the current differentiate in parallel connection, right? From point to point. In series, the voltage differentiates. At this point, the voltage would be different compared to this point. And when we'll calculate, if we'll sum up all the voltages, then it will be equal to this voltage, right? That was what the principle was. So we'll see what's happening here. So I'll go with the circuit once again, the multimeter circuit. So I did nothing. I took a resistor of 1 kilo ohm. I could take 10 also, nothing. 1 to 10 is measurable. So I'm just trying to measure the potential difference within these points, right? So for the multimeter, I connected this to ground only. We could have a common ground. Okay, and to what point we want to measure the voltage is this point, right? Okay, now we'll do nothing but simulate this and we'll see the potential, right? We have 49.8 millivolt. As the intensity increases, we can see the voltage is increasing, right? Okay,
Yes.
so now we know how we can measure the value from this. We can use this particular resistor as a sensor. Okay, so I'll keep this aside only. I won't delete this. Okay, now we'll go with an Arduino and how we'll be connecting with it. Okay, I'll copy this one. I'll paste. So we have a resistor here. Now, similarly, what we have to do is the same thing. We'll create a series, right? We'll create a connection in series. Wait, sorry. Okay. We'll go back to this one. What was it? The resistors was connected to ground, and this was connected to the positive, right? So we'll connect this to ground. Okay, and we'll connect this to the voltage. We are not connecting this to. We gave this a 5 volt, right? Okay. Now we have two resistors in series, like same here, right? This was the circuit. I'll color this so we can see a different label. Okay. So this was the circuit in series, right? And we have created this circuit in series, right? Now we want the logic. Like we have to get the reading. So we got the reading from this point, right? Just before this resistor. So we want to measure the voltage from this point, right? So for this point, we'll connect it to any of the pins, right? For now, we'll go with a digital pin, right? No worries. we are going with a digital pin right now. Now, I think the circuit is complete. Now we'll go to the code part. Okay, there's one more thing. If you are not that fluent with code, they also have something called a block method. I think someone would have, if ever saw on Sketch how the Sketch works for kids, they teach them programming, right? So you can directly build in some methods and all. But I would prefer go for the code only. You'll have more command over this, right? Okay, I'll go with start only from the sketch. So we'll start revising. So we had the first function. The first function was setup. If everyone remembers, the first function was setup. Okay. And what we did in the first function was let Arduino know what the pin 3 is connected to. Is it connected to an input device or an output one? Okay. So this case, we want the input value. So we'll define in pin mode. Okay. Pin mode. And pin mode takes two parameters, right? The first parameter was the pin number, and the pin number that we gave here is 3. And the second parameter was what is this component about? Is it an input? What will be using this pin for? For an input or an output component? Since we are using it for an input component, we want a value from this photoresistor. So we provided this as input. So we are done with setup. As soon as we are done with setup, this will take us to the extended bin. What we call it as extended bin. It's not the term for this particular function. That's what I like to call it. So, okay, loop. So as soon as the compiler hits this particular function, it will directly go to loop. Uh, you can see we are not calling this method, right? It will directly go to loop. Okay. So now we are in loop. Now we want to measure the value. So if we want to measure the value, we have a predefined function for that as well. So we'll recall something. For the output value, in order to switch on and give the voltage in that, we had a predefined function called digital. Right. Okay. This was our predefined function. Okay. Now we want to read a value, not write on it, right? So we'll just change this for read. Nothing fancy. Okay, we change this to read, digital read. Now we will be reading a value. Now this particular pin doesn't require to turn this on and off, right? Because we are not giving a voltage. So this takes only one parameter, that is the pin number. Okay, so we'll just give 3 here. I'm sorry, 3. Okay, digital read. But this returns a value, right? Since we are getting a value, then this function should return a value. If ever you are confused with it, we can go back to Arduino reference. We'll go back to the references, and we see we have digital read here, right? So what digital read does is reads the value from a specified digital pin. Our specified digital pin was pin number 3. Okay, we want to read the value from a specified digital pin, either high or low. So this will read high or low. Okay, either the value coming from it is high or the value is low. And the syntax we have, we see we have only one parameter, right? Pin. It will define the pin number. Okay, and it returns a value. It returns either high or low. Okay, so and I previously told you that for us, high is equivalent to 1 and low is equivalent to 0 in case of digital. Okay, high would be equivalent to 1 and low would be equivalent to 0. Now we have to define a variable to store the value, right? Like, so int, we take an integer value because we want 1 or 0, either 1 or either 0. Well, equals to digital read. Okay. So this is complete. Now the Arduino would be reading the value. Okay. Now if I simulate this, Arduino is definitely reading the value, but we don't know about it, right? We can't see any value right here. Where would we see the value? So in order to see that, we have a serial monitor here. Okay. In Arduino, we will be having a serial monitor. So we'll close this. But what happens is we have to let the serial monitor know that we want to display a value. It's same as we are doing a print, right? So in order to do this, we have to do two things. We have to start the serial monitor. In order to start the serial monitor, we'll use serial.begin. We'll start with serial.begin and we'll give it a mod value. We'll give it at 9600. Okay. Just ignore 9600 right now. We won't talk about it. It's bandwidth value something, but we'll come to it in future. For now, you can just give 9600. No worries. Just ignore everything. Ignore if it has a parameter. Okay. So now what happened is now the serial monitor has started. Now the serial monitor will know that we are trying to call it for some work, right? So we called our serial monitor now, but we want to print the values. So still nothing fancy. Serial is nothing but a class, right? And we know how to use a function within a class. So begin is a function within this class. So to use another function within this class, we'll use serial dot, and we want to print a value. So we have nothing but print. Okay, and we'll print the value as well. So whatever the value was recorded using the digital read, it will print the value. Okay, now we'll start this. Okay, semicolon. Anything else? Yeah. Okay, we'll open the serial monitor and we are getting the values in 0, 0, 0, 0, 0, 0. And if we move the intensity here and there, okay, we are not getting the value. Okay, yeah, it's coming after a, wait, is there something issue? Wait, I'll use another method called print line. Okay, this is nothing but a print line. Print ln is print line. So we'll get the values in one line. So we don't have to check much. We read from this and okay, we are getting this in a row. Okay, see the value turned from 0 to 1. There was a threshold between this value. We can see. Okay, somewhere in between there was a threshold. So before this threshold, it will take 0. And after this threshold, it will take 1. It's not giving you a precise calculation because we have used digital. Digital is all about 1 and 0 only. So if it's above threshold, it will give you 1. And if it's below threshold, it will give you 0. Okay. In order to get precise, not digital values, in order to get more understanding of the data that we are getting from this, what we can do is we can use these analog pins. So for analog readings, for digital reading, we have 1 and 0. For analog readings, I'll tell you, okay, I have to stop simulation first. For analog reading, the values go from 0 to 1024. Okay. Now, this 1024 is dependent upon the bit rate of this particular microcontroller. For this, it's 2 to the power 10. 1024 is nothing but 2 to the power 10. So we'll get the value in this range. Now let's do that. Uh, now, here we'll come back to that question where someone asked that we could connect this to analog as well. So now what we'll do is we'll connect this to analog as well. How should it go? I'll let it go, right? We'll connect this to A0. And I'll give this stepwise something different. Okay. Same sensor. We have connected we are getting the reading from digital pin and we'll be now getting the value from analog pin as well. Okay. For this particular sensor. Right. So for any sensor, we could either get the value in digital or we can get the value in analog. In some cases, we can get the value in both. Right? We could precisely use the circuitry within our understanding and we'll use the value in both. Okay. So now it's time to go analog, right? We have A0. But now, since we have used another pin, we have to tell Arduino what A0 is about. If you don't tell Arduino what A0 is about, it won't know anything is connected in A0 and it won't care. Okay. So now we want Arduino to know that A0 will be using A0 for an input component. So again, we'll be using this function and the function name is pin mode. And now we have to define this pin. Now for analog pins, we have to give this A and then the number of the pin, 0. The number of the pin here is 0. So we gave this as A of 0. And this is also input. This will also be acting, this pin will also be acting as an input since we are taking the value. Okay, so same thing we'll do here. Nothing but the same thing over and over. Okay. Now, again, nothing fancy. What we were doing here was I have to declare a different variable. I'll take val1 as the variable here. And we were using the predefined function digital read. Now we want to read the analog value and we have already defined A0, right? So instead of digital, we'll use analog. See, okay, not too complicated. Just we have to, the function name is kind of synonymous, right? Instead of digital, we have used analog. So, okay. And the pin name was A0. Okay, the pin number was A0. We gave it as A0. And this will print the second variable, right? Val1. Right now, okay. And we'll start the simulation. Okay, we can see we are getting 0 and 6 value right here. But we can't make it out for because the value is populating too fast, right? So we'll make this a bit pretty. So what we can do is we can give a print. I have to stop simulation. I'll give it as print well. And so what print does is print will print whatever text or value you have given here. It will print all of it in a line similarly. And the print line, as the name suggests, it will go to the new line. This function will go to the new line and then print this value. Okay. So what we're trying to do is we are trying to make this a bit fancy, readable, not fancy. Dot print and we'll give a string. We'll give a space, we'll give a comma, and then we'll give this, right? Okay, and then we'll print this, and we'll just go get the cursor to the new line. Print ln. Okay. Print line can work without a parameter also. Okay. In this case, it will just go to the next line, nothing else. Okay. Oh, okay. Now this is kind of readable, right? So this value, the left side value, the first value is the digital value, and the right side value is the analog value, right? Now we'll increase this. See, we are getting 6. As we increase, right? See, we are getting more and more. As the intensity increases, the analog values are increasing simultaneously, right? And somewhere within the threshold, I told you that the analog value ranges for 0 to 2 to the power 10. 2 to the power 10 is nothing but 1024, right? So threshold, theoretically, threshold will lie somewhere within the half of 1024. That is 5112, right? So somewhere within the 5112 it's changing from 0 to 1, right? That is the threshold. But in real life that would not be the case, since I told you there would be noise, right? I'll cover what kind of noise we'll be facing here and how to filter that in later sessions. Okay. So we can see we are getting analog values, and this went to maximum of 679. It might be due to the resistance or something here. It didn't go to 1024, but that would always be the case, right? It won't surely be go to 1024, but the value is the maximum value that could it range to is 1024, right? So now we are done with the LDR sensor, and we have taken both the digital as well as analog values, right? Okay. Now, do anyone has any question in this one? Yeah, I'll come back to see that. Okay. Do we have any question? I think how to check resistance value for component. Yeah, V equals to I. That's correct. That's how I'll be calculating the resistance. Can we connect a component to the digital pin and analog? Okay. This also we covered, right? Any other questions anyone has, if in case?
No questions, I guess.
Okay, no question. So I'll take it as everyone understood, right? Okay. So I think we are already past 130, right? So this is, so I'll tell you something. So you guys can go on and log into Tinkercad to create the designs and all. You can just go to design and circuits. So you have three things that you can create within Tinkercad. You could create a 3D design, a 3D model of anything, a circuit, and a code block. So code block would be included within the circuit as only is the coding that we saw. So we'll go to the circuit part and then we'll go to create, right? To create something new. And then we could proceed. The 3D would be we'll be using 3D also when we'll be designing the bots. Then we'll use this 3D. This kind of fun. So it has everything and all. I'll show that later. But what I really wanted to show is I'm trying to create a class here so that you guys could get all the circuit projects that we are creating here, right? So I was planning to cover this one as well. So I created this one. This was about controlling two motors, right? And these will be controlled bi-directional. Like you can control. Uh, uh, Sorry, you can control the direction of the motor for both the motors, right? So I think this I'll cover in next session only. We don't have much time. So for now, I wanted to cover one thing. I'll just stop the recording here. Okay.